This is Seth Beyer, section 021, and this is Lab 5, problem 2 of coordinated move function, which is going to have four inputs, the xy of the initial and the xy of the target. Excuse me. And we're going to be using these to calculate for everything else. So, like always, I create my variables, I set the pins and the Arduino, that's all set up. And then I move to home again, so you're always starting at the same spot. This one is, it's just taking steps towards the back limit switch on the X and Y axes until eventually that limit switch lights up, and then it will stop doing that. And then I move towards the initial spot, which is basically doing the same thing for the home, except we're doing 4 loops, and we're doing 1 through the initial X and then 1 through the initial Y points. And you're just going to step in that X direction until eventually it just hits. And then it will stop and continue on into the Y. So we'll start with the X, and then we'll go into the Y, and then that's right at the initial position. And then I update that to show where the initial position is, and then I enable the tracker so you can see the movement between the first and the second. Important thing to remember is that this code is going to be working best when the target position is basically in the first quadrant of the initial. So imagine like a little graph right here from the initial point. The target position always has to be in quadrant 1, because if it's in quadrant 2, 3, or 4, it's not going to work out as nice. The slope always needs to be positive and in this first quadrant, basically. Speaking of slope, we calculate that. We set the... Hold on, lost my spot. Here we go. We calculate the slope because we're going to need that for further calculations. And then we set the right digital pin to go of the X and Y direction to go away, since we're always going to be moving this way, which is towards the away position at the top right of the XY table. So we always want the X and Y directions to be going away, since, like I said, it's going to be in the first quadrant from the initial point. Next, we have these two big if loops that basically control the when the X and Y will step. So for the X step first, we have slope is less than 1, which is essential for taking the X step first. Then I use X as a difference between the two X values. I make a counter that starts at 1 and a counter that starts at 0. The counter that starts at 1 is going to help how do I explain this? When it's going to be 1 before X even takes a step. So that way, when X takes a step, we can see in the if loop that it already took a step. When you'll see, just as I continue on this code. And then I also find theta by taking the inverse tangent of the slope, which I Googled to find out. And then we have this while loop, which is while the X count, which is 0 to begin with, is less than the difference between the initial X and the target X, you're going to take a step. So this while loop right here will happen until the X count, which counts after every X step, has the same number as X, which is the difference in the two X values. After that, we have an if loop, which is taking the counter times tangent theta. That is by using, I'll show you. That was by using all these calculations down here. So like I said, this count tool, it is at 1 before the X even takes a step. So it's basically pre-allocating before that even happens. And then what's going to happen here is that if that count, which is 1, it counts how many X steps. If that times tangent theta is less than 1, it's going to add another to the count to show that there would be 2 steps taken before 1 step of the Y direction has been taken. So this count will happen every time until count times tangent theta is less than 1, less than 1/2. And then if it happens to be greater than 1/2, it's going to take a step in the Y direction, and add 1 onto the count to show that it's going to set count equal to 1 again to restart it. Because what we're basically finding is how many steps in the x direction do we have to take until this y value is 1/2. So I have it doing that it's going to count every x step it takes until this is 1/2 or greater than. And by doing so, I have, like I said, I have this counter in place. So see how it's counter 1, which means that when it goes back into this while loop, it's already planning for this x step to be taken. And then if it's not, it just adds 1 and takes another step. But it's just like a little bit reverse. It's a little confusing to understand unless you just are looking at this, I guess. Anyways, it works fine. I don't know why I'm explaining this so much. I should just show you. Hold on 1 second. And then I also just have this if loop for the y direction. So just doing one off the top of my head. Coordinated move. I like to just do 1, 2, 3, 2, 3, 4, 3, 4, 5, 4, 5, 6. And okay. Where's the enable tracker? 1 second. There it is. Try that again. Coordinated move 1, 2, 3, 2, 3, 4, 3, 4, 5. And I don't have the Arduino variable set into here because I have it already set in every function by itself, so I don't need to constantly be typing FD. I don't know why it's not showing this. Let me try one more time. Move. Let me just try some different numbers. Let's go 100, 100, and then let's say that we want the x to step first. So that means we're going to want a greater x than a y. So we're going to say 600x and 200y. Plug that in. Oh, there it's working now. So as you can see, it obviously straight line right there. I'll try another one. Switch those numbers around. Coordinated move. Let's go 100, 100 to 750, 350. Or, oops, let's go 350, oh my lord, to 750. And as you can see, yet again, straight line. And this will just happen for everything for any coordinate they put in, as long as it's always positive, like I said. And that's it.